as I said, thanks for the presentation. Thanks for the invitation. I'm going to speak about a work by Mika Norlén Jäderberg, who's my PhD student in Linköping, who's been working with certain functors between higher cluster categories that in certain cases allow us to take a cluster tilting object in one cluster category and break it apart into cluster tilting objects in some way easier cluster categories. So the basic setup is that, well, K is a field, any field. D is an integer greater than or equal to 2, and L is a positive integer. So when I speak about the D cluster category of type AL in this context, I mean that we take the bounded derived category of a quiver of type AL, and we take the orbit category with respect to the Nakayama functor shifted by negative D. So if you input t equal to 2 into this construction, you will get back the ordinary BMRRT cluster category of type AL. I should also perhaps warn you that there is some clash of terminology here. What I call the D cluster category is by some people called the D-1 cluster category. So these categories have been given a geometric interpretation in the classical case by Calderó, Chapeton, and Schiffler, and in the higher case by Baur and Marsh. So if we let n be this number, which you see, you can't. Can you see my cursor, by the way? You can, good. And you consider an n-gon, a diagonal in such an n-gon is what we call a d-diagonal. If the distance between the 2 points, -1, is divisible by d-1. And it turns out that d-diagonals in this n-gon correspond precisely to intercomposable objects in the cluster category. And as I said, moreover, there is some more information to be read off from this picture. So if you have a collection of d-diagonals that do not cross each other, that corresponds to some x vanishing. And if you take the direct sum of such a collection of objects, you will get a d-rigid object. And if you take a d+1 angulation of your n-gon, which is simply a maximal collection of non-crossing the diagonals, that will correspond to a d-cluster tilting object. You will also notice that if you have the number n, that does not in general determine uniquely the numbers d and the numbers l. So in case you have some other d prime and some other l prime, and they satisfy this condition, this relation between them, then, well, the cluster categories are visualized in the same polygon. They have the same n. Moreover, every d prime diagonal in this polygon will also be d diagonal, but not the other way around. So notice that I write A for this number. So what this means is that we can view every object in the d prime cluster category as an object in the D cluster category. We get an injective map, an injective embedding of objects in the D prime cluster category into the D cluster category. And since if stuff don't cross, they don't cross, if you have a D, if diagonals don't cross, then they don't cross. So if you have a D prime cluster tilting object in this cluster category, it will still be D rigid here, although it will no longer be a maximal collection of diagonals. So it will not be D cluster tilting. And it is then natural to ask if this embedding of objects comes from an embedding of categories. And the answer to this question is no. But it still turns out that it comes from a functor. So the result is the following. It was first proved by master student Van Roosendaal some years ago, but Mika has produced a more conceptual proof, which is nice. So you have your D cluster tilting, you have your D cluster category. You consider an A-fold cover of it. So you take the same derived category and you take orbits with respect to Nakayama shifted by negative D to the power A. This gives you an A-fold cover of your cluster category. And the other cluster category will not embed into the cluster category here, but it will embed to this one. So this is the result, that there exists a full and faithful functor from the D prime cluster category to this covering category. And if you compose this with the natural functor from here down to the cluster category, you get a functor which realizes the embedding of objects. Moreover, since if you assume that your characteristic is different from 2, you may view algebras of type D as skew group algebras, certain algebras of type A. And using this skew group algebra construction, you can move the entire result, or almost all of the result. You can move it over to type D also. There are some things you need to check manually, but in principle, with some work, the result translates to type D. Yes. So as I said, our functor G, this one, it is injective on objects. It sends cluster tilting objects here to D-rigid objects here, which are no longer maximal. So you will one may ask the question how to complete such an object to a D-cluster tilting object in the D-cluster category in here. And so if I denote by ED of, well, G of T prime, the set of objects in the D-cluster category which satisfy this X vanishing condition with the image of T prime. So all the X from 1 to D minus 1 will have to disappear. And now, with some work using results by Jacques Malot, you can show that if you take this category and you take the Yama-Yoshino reduction with respect to this image of the cluster tilting object D prime, this is actually isomorphic to L+1 copies of this much smaller D cluster category. So it's D cluster category of A minus 1. And what this leads to is that if you want, in order to complete the image of T prime to a D cluster tilting object, what you need to do is you need to choose a cluster tilting object in each one of these smaller categories. So you get the correspondence between D cluster tilting objects in CDAL, which contain this image, and GT prime with D cluster tilting objects in these smaller well, L+1 tuples of the cluster tilting objects in this smaller cluster category. Final remark is that that not all cluster tilting objects in CDAL will contain such an object. They won't. Sometimes there is no reduction that you can do, but quite often it actually does contain one, and then you can reduce to these smaller cluster categories. Time is up. Thank you for listening.